Okay, so we are now finished with gases, and now we're just about ready to start talking about the laws of thermodynamics. But before we do that, let's just review what do we know about what work W is and what do we know about heat Q. So work W is going to be the transfer of energy to a system through the organized motion of molecules. So in that first picture there, it shows a solid, and it's composed of these atoms that are all hooked together. And then we're going to apply a force to it, and then that's going to move it a distance r. And we said that work W was force times r. So notice that every atom is moving at the same rate, and so it's organized. So when this thing moves over to here, each of the little atoms, they're all moving in unison. And so work is the organized motion of molecules. And so work is going to be given by force multiplied by a distance. Now on the other hand, heat is going to be caused by the disorganized motion of molecules. And so in order to think of this one, think about the same object, but this time instead of applying a force to it, let's assume that there's like a candle underneath it, and we're going to apply heat to it. So as heat is being transferred to the system, so here's the system again, heat is going into the system, it's going to cause this atom to start to vibrate. And then when that one vibrates, it might cause the one on top of it to vibrate. And then as it vibrates, it might cause the one over here to start to vibrate. And notice that those vibrations are random. So some of them are up and down, some of them are sideways, some of them are at an angle, but it's disorganized motion. If this was a gas and you applied heat to it, then in the case of a gas, then what would happen is maybe this air molecule would go this way, and then this one might go this way. And so all of these air molecules are moving around with different speeds and in different directions. So again, it's unorganized. So it's the transfer of energy to or from a system through the unorganized motion of molecules. So that's the definition of Q, which is heat. Okay, now let's pretend that the system starts with a certain amount of energy. So the system, so we're going to say this box here, begins and has a certain amount of energy E to begin with. Now we could either do work on the system, or the system could do work on you. Okay, so if it was a box, and then the box, you push on it, and the box moves, then you're doing work on the system. And what you'll do is you'll increase the energy of the system when you do that. Now on the other hand, if that box falls on you, then the box does work on you, and it gives energy to you, meaning it hits your head and it hurts. So notice that work could either be added to the system and the energy could increase, or the system could do work on you and then the energy would decrease. So notice we need to have a sign convention for work. So if it is positive work is going to mean that energy is going into the system. And then negative work means that energy is coming out of the system. So the energy of the system is going to decrease. Now we could do the same thing with heat. So again, we could say that there's a candle down here, and we could add heat to the system. So that's what the candle does. The candle is adding thermal energy to the system, so the energy would increase. So we would say that that's positive Q. Positive heat means energy is going into the system. So what do you think, what's the other thing that could happen is, let's say that you've got a stovetop, which is very hot, and you put your hand on it. Which way is the energy going? So heat is always going to go naturally from hot to cold. So the heat from the stove is going to go into your hand. So if the stove is the system, then heat could come out and go into your hand, and then that would be negative heat, negative Q. So we have a sign convention for heat and work, positive and negative. And notice that if it's positive, it will increase the energy of the system, and if it's negative, then energy is coming out and it's going to get smaller. So we say heat plus work equals the change in energy of the system. If it's positive, energy is going to go up. If it's negative, energy is going to go down on it. And so we're going to call this the internal energy of the system. The energy that the system initially has is the internal energy. And so its internal energy could be atoms that are vibrating, or it could be atoms that are rotating, or it could be atoms that are moving around in there. But as a system, let's say it's a cube, so that system could have external energy, meaning the whole thing could be rotating, the whole thing could be moving sideways, or the whole thing could be vibrating. So it depends on when you take a look at its external energy and you add it to the energy of its individual atoms, we're going to call that the total energy of the system. Let's take a break. When we come back, we're ready for the laws of thermodynamics.